evening. I'm Derek Howe, your Director of Engineering. And you just had a chance to hear from Jason and Seaver, a couple of the engineering staff who could tell you a few things about the service that you don't always see, but it's necessary to bring you safe and reliable electric service in a rural area. I'd like to clarify one point Seaver made. He talked about the right-of-way requiring manual clearing. And while that's true on a large portion of our system where we have tribal lands or forestry lands, there is a significant portion of our system where we do use heavy equipment, of course, to reduce the cost of the right-of-way. Another thing that we do to reduce the cost of right-of-way is spray. Because spraying, if we can spray instead of trim, it actually can reduce our cost by upwards of 50%. And the right-of-way budget that we set each year is one of the largest budget items in the budget each year. It's $3 million. The reason we put so much money into the right-of-way budget is because when you look at the number of outages we have, there's really no bigger factor in the number of outages you have than the vegetative growth in the right-of-way, those tree contacts with the line. So it's very important that if we want to get the best bang for your buck, that we aggressively attack that right-of-way. Well, the reason we do spraying is to reduce the cost. And by reducing the cost of the right-of-way system, I understand there's impacts, but that's why we leave those door knockers on, so that there's a contact number on there for you to contact us. And we're more than happy to work with you to try to make sure that we don't spray in areas that you want us to not spray in. The chemicals that we apply have been approved by the DNR as safe for use in wetland areas, so that we can assure you they're not the same chemicals that we used to use before. They are safe chemicals, and it is a very important part of our right-of-way management program to reduce those costs. Michelle, if you could hit the next slide. Right here what we're showing is, it's called SAIDI. It's the System Average Interruption Duration Index, which is really a fancy way of saying how many minutes are you out of power as a member of Lake Country Power each year. And this really shows what we've done with the right-of-way program and the money that we spent on the right-of-way program. You can see there's some ups and downs because, as you know, we've had some issues with weather over the past few years, but you can see the downward trend. And the bottom line is that members today are out of power about 40 minutes less than they were before we started this investment in the system. This slide really tells two different stories. The first story this slide says is, you can see this barn. It was put up by hardworking folks who came up into this rugged northern Minnesota country about 100 years ago and put these barns up. The same folks that formed the cooperative 75 years ago. And as Carter said, the cooperative mission back then is the same mission we have today. And that's bringing safe and reliable power out in a rural area where it wasn't cost effective for other utilities to do it at the time. So that's still the co-op mission today, is to bring safe, reliable electric service in a rural area where it's not profitable for other entities to do so. And that's why we're not for profit. The other story that this slide says is you can see that barn is not in the best state. And the reason that is of course, money wasn't spent on maintaining it, proper maintenance. It's about the same age as our poles and lines that are in the system. So it shows kind of graphically what would happen if we didn't invest back in the system and what our system would look like. It wouldn't be there to give you the reliable service that you come to deserve and expect if we don't stick those maintenance dollars back into the system. And these are some of the folks and equipment that it takes to make that happen, so that when you flip your light switch on, whether it be once an hour, once a day, once a week, once a year, you want that light to come on when you flip it. And it takes people and equipment like this to make that happen. Carter mentioned the $42 facility charge. And another way to express that is that it costs us $4,000 a mile to operate and maintain our distribution system. You might ask, what goes into that $4,000 a mile? Well, that's the meter, that's the loop, the transformer. That's actually maintaining the right-of-way, which doesn't stop growing. It's also the bill that you receive. It's the wonderful load management programs that we have, like dual fuel and off-peak, that Mark will talk about later. It's also energy audits that are available through our member service department, and eventually rebuilding that system when it becomes end of life, so that system remains current for you. Because some of you might say, well, I've been on a Lake Country Power member for 40 years. I've paid my facility charge. Well, the part that's ongoing is, of course, the right-of-way growth continues to grow, and that system all that equipment does have a finite life. It needs to be replaced. Now that we know a little bit about what goes into the $4,000, you might ask, well, is the cooperative doing all it can to keep that cost as low as possible? And I'd like to talk about a few of the factors that make that cost what it is. The biggest single item is line density. And if you look at line density, take Duluth, for instance. There might be upwards of 40 to 50 members per mile in a municipality like Duluth. You compare that to Lake Country Power, we have 5.9. So if our operating maintenance costs are $4,000 and you have 40 people to divide those costs amongst, that is $100 a year, or that is your $8 facility charge if you were to compare us with some of the other utilities. You take Virginia or Grand Rapids, they might have 25, and you'll see those $15 facility charges. But if you take 5.9 members in that $4,000 cost, That number is more like 666, which is your $42 facility charge. That's the single biggest factor is line density. There just isn't enough people to distribute those costs amongst. The next question you might ask is, what other factors cause that cost to be 4,000? Well, if you look at the geographic area that Lake Country Power serves, we serve just north of here. You look at Babbitt, you look at Ely, or that's all ledge rock. We have to dynamite those poles in. We have to put metal ledge sets up. That really drives up the cost of construction in those areas. We also have more lakes than anybody else, which means we have more underwater cable. Underwater cable is expensive to put in and maintain. I already talked about the right-of-way and that we have some of the most aggressive vegetative growth anywhere in the country. And then you couple that with the harsh winters we have and the protective measures we have to do for our equipment with the winters. All those drive our costs for construction. If you were to kind of lump sum average them, overhead, underground, three-phase, single-phase, you're looking at about $100,000 a mile for construction costs. And at $4,000 a mile, that really is 4%. We've kept our O&M cost to 4%. And one comparison I can make is something that we all do operation and maintenance on is our automobiles. If you look at your car, if you have a $20,000 car, 4% of that's $800 a year. And if for $800 a year you could get your tires changed, your brakes changed, all your fluids changed, your battery, your starter, all of that so that when you went to turn the key every time it was reliable and worked. But even more importantly, when that car was 10 or 15 years old, you got a new car because we do replace the system with that facility charge as well. I think that puts that 4% into kind of perspective. Here we're showing the large geographic area that Lake Country Power covers. You can see we cover all the way up to Ely, over to Orr, down to Walker, down to Sturgeon Lake. It's a huge geographic area. It's about 11,000 square miles. Like I said, 8,200 miles of line. And that's kind of the backdrop for this slide here, which is the electric distribution system. And what you can see here is that all the areas in red are areas that we're doing construction in this year in 2013. And we basically prioritize those in three different tiers. We call it priority 1, and that would be areas that have over voltage, or under voltage, or overloading. Priority 2 are areas that have reliability impacts or have had system growth that we need to address. And then there's priority 3, which is age-related jobs. And the reason we do age-related construction is because we have about 2,500 miles of line that's this number 8, number 6 that was put up predominantly in the 40s. It was adequate for the load at the time, but today this wire is end of life, it becomes brittle. And of course, when it gets brittle and breaks, when it makes when the wind blows or when it gets ice on it, it causes you an outage. It causes us higher costs to go out there and replace it on outage restoration. And more importantly, to meet the loads of today, we have to put up conductor like this. So obviously, there's a capacity issue as well that we have to address. But there is also another dynamic at play with our age-related investments and why we invest in age-related conductor replacements, and that is cost. If we wait and don't proactively address those age-related investments, it actually costs twice as much. If we wait until the poles fail pole testing, because we test 10% every year, and then replace the poles as they fail, and then wait till the conductor fails and breaks and go and replace it then, it actually ends up costing twice as much. And when you're talking about construction costs at $100,000 a mile, that's a substantial amount of money. So on one hand, we don't want to defer too much maintenance to where it costs future generations much more, up to the tune of 2 times as much. But yet, you don't want to do too much construction today either, because that causes too much rate pressure today. And of course, you're paying for assets today that are going to be in place for 60 years. So future generations should pay their fair share as well. So really, that's the struggle at your cooperative, is trying to balance that, not doing too much today, but not deferring too much so that it costs twice as much as well. And I can tell you, in the engineering department, we've worked very hard to try to do more with less. One example is we do 25 miles of age-related conductor replacement each year that we added over the past 2 years. We have also added 10 miles of underground replacement. And we've done that with basically 35 miles of construction, which is roughly $3.5 million, without having a significant budget increase on the distribution side. We've done that by having help from our subsidiary and reducing costs and being able to do that work more efficiently. We've done it by reprioritizing what our needs are and more accurately addressing where growth is taking place. So that's one example of how your engineering department has tried to reduce cost for you as a co-op member. And finally, I'd like to wrap it up with a brief discussion on the new meter base that we're rolling out this year. And not so much for the value of the new meter base, although if you are putting up a new service or if you're going to combine 2 services, this is the base you'll get. But more so because I think it tells an important story to you as members, that you should know the kind of discussions that go on behind the scenes at your cooperative. The problem that we had, and the reason that we started looking at redesigning this 2 years ago, was because we knew that we could save some money. We were paying about $50,000 to $60,000 a year in state filing fees that we knew we could engineer out if we made a new base. But of course, our charter is to look at ways to also serve the member more efficiently, more more cost effectively and provide better service. So we formed a cross-functional team. We actually involved members from member services, we involved linemen, we involved new service reps, stakers, engineering, all got together and kind of said, what are some ways that we could, if we're going to redesign the meter base, that we could do something for the member as well. The first thing that came up was a lot of members are putting in multiple 200 amp services, and at the time that required a new meter base for every service you had. So if you wanted 200 amps in your garage or 200 amps in your home, that needed to have two separate enclosures. So we said, well, we could probably put all of this into one enclosure. And that's what we did. If you look at the bottom, you'll see those solid bus bar with lugs. Those are multiple 200 amp connections, so we can now serve 3 200 amp connections out of one box. The other thing we did is we said, well, if we move the overcurrent device up to the top, we can make it so that the members only have to pay for 3 runs of conductor rather than 4, saving you a run of conductor for every service you have to this box. So it's just one example of many you'll hear from Mark and others tonight about how there is service going on behind the scenes at your cooperative to try to think of ways to creatively save you money and do more with less. Thank you.